Yeah, first of all, thank you very much for being here today with us at hardwear.io. We really hope you're having a lot of fun. For sure we are. So let's get started, right? So who are we? My name is Javier. I'm a hardware security specialist. I work at CodeWhite as a pro security engineer. So, we break stuff and have some fun. I'm from Cádiz, Spain, just the south. That's why I have a barbecue and stuff. South always rules. I enjoy reversing products. So I always want to make stuff do what I want them to do, not what they are supposed to do. And yeah, I like cake when it's not a lie, and barbecues, like I said earlier.
My name is Ferdinand Nölscher. I'm a hardware security guy. I also work at CodeWhite, and I do like reverse engineering a lot. I also like attacking software systems, but the hardware side, I think it's a little bit more fun. I also like lasers. That's me with the laser right there. Yeah. So.
Yeah. He likes barbecues over cake. I stick to cakes, but yeah, sure.
Yeah.
So yeah, let's talk a little bit, a brief introduction about the current car hacking status. So yeah, right now it's more on the remote part, we could say, so starting to get there, but most of the focus is on the canvas itself. So yeah, there are like replay attacks and packet injection, which is like the small phone we have there, like record yourself and then like play it. Some researchers also found some remote exploits to take control of certain vehicles or parts of it. Actually, there was one not too long ago. And yeah, there are some tools which are pretty useful to help us understand the UDS protocol.
But the CAN bus, it's like only the transport layer or even a little bit lower. And the protocols on top of them are really interesting as well. Because you might have heard UDS or TP 2.0, which is short for tunneling protocol. They also take place on the CAN bus, but they do offer a lot of interesting services from an attacker's point of view. They're like used for servicing vehicles. That's like the first use case you would think of, but you can also do a lot of other stuff as well.
Yeah, we'll know that sometimes vulnerabilities are related to the firmware versions. So one of the samples with these services, you can actually gather all the information from the software, from the ECUs. You can attempt to read the firmware from them, like trigger actions which are not so obvious initially. So there are a lot of fun to play with. And yeah, to get started, what's UDS? So yeah, UDS stands for Unified Diagnostic Service, and it's present in pretty much all modern cars. It provides access to the services offered by ECUs because ECUs are servers. I mean, when you are connecting to an ECU, you're a client accessing the server services. So yeah, it takes place on top of the CAN protocol. So it's a layer 4. And UDS allows to perform transmissions, so to send messages of up to 256 bytes. That's because the length is specified in a single byte. And it is just a transport protocol. I mean, the name itself is sort of misleading because it's like a diagnostics service, but it is just a transport protocol, so you can put any data on it.
So UDS, like a CAN frame can hold up to an 8-byte payload, and UDS helps with fragmenting the transmissions. So there is a single frame transmission, and you can stuff 7 bytes in there or less. And then there's multiple frame transmissions, which means your payload is bigger than 7 bytes, and it's hacked up into different pieces, different CAN frames. Yeah.
So to get it the other way around, if you want to send more than 7 bytes in the payload, you would require more than one CAN bus frame to send the whole message. And yeah, what kind of frames exist in UDS? So there's not that many. There's without ACK request, part of a multi-frame transmission. That means that the message is more than 7 bytes long. So yeah, and no ACK request is obvious. So the same thing, but with ACK request. The only thing that changes is the first byte of the transmission, of the whole transmission. And then on every single frame, there will be always the first byte, which is consecutive, to follow up, just in case the server or the client misses a frame. Then there's like a single frame, which the first byte is 00 plus the length. So if the length of the payload is 3 bytes, it would be 03, whatever. ACK, which is a single byte, 30, and yeah, NAC repeat transmission is I think 90 or 95 or something like that. It was lost during the slides.
So TP 2.0, as already mentioned, stands for tunneling protocol. And it's also present in some ECUs, like depending on the manufacturer, they like prefer TP 2.0 for their stuff. And it's also used for internal communication. I mean, keep in mind, they like make it very easy for you to split up, to send more than 7 or 8 bytes in a CAN frame. So that's why they're used. It used to be a port for the K-line protocol, like that's like the predecessor of TP 2.0, so to say. And again, it's just a transport protocol. So it takes placed on top of the CAN protocol itself. And it allows you to perform transmission up to 256 bytes.
So yeah, it's pretty similar to UDS. It's just like there are some, how to say it, some opcodes that are different, and the structure is a little bit different. So yeah, again, pretty much the same. There are two kinds of transmissions, single frame transmissions, but here we can only put 5 bytes of payload on a single frame. If we have 5 bytes or less, we only need a CAN frame. If we have more than 5, we need to use more than one CAN frame to transmit the data. And again, I'm not gonna go through the whole thing, but so you see how similar they are. Yeah, still good. So same operations, just some codes like the ACK was like 30 on UDS, here is B0. But in the end, it's pretty much the same thing. And now the SIDs.
Yeah, you can see that the naming schema, it's a little bit unsharp. You know, the names are different, but the main difference is like the SID, the service ID codes. You can see on the second left column. Yeah.
Yeah, so you see like the 2 columns. I'll work on it. So on this column here, you see sometimes it's, I do have a laser pointer. Wow, such technology, man. So you can see here, there's actually like 2 columns in one. So when you see, I guess you don't see the values, but when you see 2 values, it means that UDS and KWP, which is pretty much tunneling protocol, have different SIDs, but some are shared. So that's one of the main differences between tunneling protocol and UDS.
So there are a couple of services which we would like to mention here that are interesting from an attacker's point of view. The first is like the security access, which is the authentication from the tester to the ECU. So that's like the authentication, and you need to have security access to access like services that do write operations or are like more critical. Then there's read memory by address, which is pretty self-explanatory. It allows you to read certain memory addresses, like you give it an offset and it will return the data. Read or write data by ID means that there are already certain values that are known. For example, you can use an ID to read the vehicle identification number. But there's also like other stuff to trigger. A request upload is used to retrieve the firmware from the ECU. It's a little bit misleading here. It means like the ECU is supposed to upload the firmware to the tester, to the PC. And routine control can start like routines which take a little bit longer, for example, resetting the ECU or erasing the flash.
And some other fun ones, which are like depending on the vendor. So yeah, with all this stuff, so say hello to the CanBadger. That's a little guy, and glitch is gonna glitch. That's for someone special. So let's talk about the CanBadger now, after this intro. It's powered by an Mbed LPC 7068 or an LPC Espresso 1769. The latter has a debugger embedded on it. It has 128 kilobytes of external RAM. It has 2 DB9 CAN interfaces plus 2 debug headers. It has an SD card to store the dumps, to store logs and everything. ECU power is controlled by software, so you can actually turn the ECU on and off from the software interface. It has UART, it has 4 GPIOs if you want to add some blinky LEDs or whatever. And it has a standalone mode, so no computer required, USB mode, which is a CDC device, and a network, it's gone, network mode. It can be powered either by a power supply, by a external battery, or by OBD2, plugging it straight. Yeah. It has the blinky dual color LED, which is funny and stuff, and the whole board is under $25, so it's quite cheap.
So I'm going to talk a little bit about the firmware features that are currently implemented. All the actions on the CanBadger are handled by the firmware, which means it's not yet another interface, but it's a standalone tool. It supports UDS-TP 2.0 and of course RAW-CAN, not just logging but also parsing. We'll actually show that. It supports a man in the middle, so you have like the two interfaces and connect to one bus at one, and like the output is at the second one. You can modify the packets on the fly. And because the rules are stored in the SD card, you can actually configure it on your computer and then take it into your car. And you don't need a computer for that. We're going to show you the security access hijack later. It's somewhat newish attack. It can emulate SIDs and PIDs from a log, so you can say like, I will record me driving to the supermarket, and then you can replay this data. Well, actually not replay. For example, in the use case, you have a dongle that requests information from the car constantly. Then the emulator will wait for those requests and remember the point in time which data was returned. Well, we're going to get into more detail from that. Data transfers can be done to the SD card, which is especially useful when you're on a car that distributes firmware updates to the modules over the CAN bus. And of course, logging UDS-TP, RAW-CAN. It will also detect the CAN speed for you.
That's quite useful. Yeah. Like, yeah. If you have ever dealt with a vehicle, detecting the CAN speed saves a lot of time.
So you don't need to care about that. And also, as already mentioned, it supports 3 modes of operation. One is the standalone one with nothing attached, just the LED as an output and the button for switching through the modes. The second one is the CDC mode. And the third mode is the Ethernet mode, which you can use for controlling multiple CanBadges over Ethernet.
Yeah, all fancy and blah, blah.
Yeah.
So, yeah, let's talk a little bit about protocol analysis. Yeah, still visible. So, yeah, many SIDs are already included in the firmware. The firmware is already out, so you guys can just like download it straight after the talk if you have not done it already. So it's extremely fast to add support for new SIDs. It's just a switch case. So you just like add the byte and then add the actions. It is extremely highly verbose. It gives you all the data for all the parameters. Yeah, like we were mentioning earlier, everything is done by the CanBadger firmware. You don't need to install anything, just have a terminal. And the logs are stored in the SD card, just to make it more standalone. And they can be either viewed or retrieved from the CanBadger without having to remove it over the GUI. And it works with both UDS and Tunneling Protocol 2.0. And yeah, for the Tunneling Protocol 2.0 and UDS interactive session, no scripting is required. The way this works is you just, we will see it. You just start a session with ECU, and then you get the options. The session will stay alive. So then you get to try stuff. Like, okay, let's try to scan for this. Let's try for this ID. You get errors, you succeed. Okay, now let's try adding test address. Let's try removing it. Let's try changing the test address. Everything is done in real time. You don't have to try and try and try. So you can go back and forth easily. And it has some built-in scanners for SID parameters, which are also like really useful. And the server.
The CanBadger server is made for making the CanBadger even easier to use. We were mainly inspired by Burpsuite there. That's why we chose the topic, attacking cars Burpsuite style. So the point is you can not only control multiple CanBadgers over Ethernet, so you can just leave them in the car somewhere in different bus networks. Then you go back to your computer, you can rename them to know where they are. and use them in parallel. That's also very handy if you want like to script. So you can do like automated tests or fuzzing. We actually tested the CanBadger with another CanBadger. Yeah, so really cool stuff. The Ethernet protocol is pretty simple. It will just broadcast every 2 seconds, hi, I'm here. And then the CanBadger server will connect. We will send a connect packet, then it will poll for commands until it gets like stop current action or action finish. Command will be like lock CAN traffic or replay a packet, and once that's done, it's going to be polling for another action again. So a good demonstration of the CanBadger server would be the man in the middle. On the top picture, you can see the original traffic that I think it was an ECU was sending. And on the bottom, you can see the changed traffic. So what you will do is you will go to the GUI and set up some rules, like match and replace. You can set rules for specific IDs, and you can manipulate individual bytes. So you will define a mask, which will say, okay, I want to change the first, the second, and the last byte. You don't have to swap out the whole payload. You can do some math operations on the frames. Pretty much everything you can do there. Actually going to show that right now.
Yeah. So the good thing about this is just as a quick sample. Let's say that you have some black box or something that's like checking on your speed and you really want to go and speed up. So what you would do in this case with the man in the middle, everything would be like straight, but then you would add a rule for the specific PID to change the bytes that represent the speed and divide them by 2. I don't know, or just whatever. So I don't know if it's actually too visible. Like the timing is like 20 milliseconds everywhere on the original, and on the other end is still 20 milliseconds.
That's
so
really
I mean, the device that's receiving the modified traffic just cannot tell the difference. It's really, truly real time. There's no actual delay, and the data gets modified. So yeah, in a talk, let's see it in action.
Right.
There you go. Yeah, I need to reset the guy so it gets into Ethernet mode.
There we go.
1 second.
All right. Gonna move it a little bit.
There you go. You see this more?
Right.
Oh, okay.
So that everybody can see that.
So, yeah, that's a CanBadger server.
That's the server you can see right here. So once you turn on the CanBadger and connect it to the network, you will see all available CanBadgers on the left. That's like the sidebar. So let's connect to this guy. Yeah. Or also called it Ferdi CB. That's my CanBadger. Yeah. And now for every action you do on the right, you have to select the CanBadger here. Now let's log some simple traffic first to demonstrate the logger. There we go. It's also pretty fast. You can sort it like by frame count, for example. So the newest stay always on top. You can filter by IDs. So I'm actually gonna be interested for those, but also for this one, for example. You can also show only IDs that popped up after a certain amount of time. For example, I want to leave my CanBadger running, and then I'm going to perform an action on the car, such as unlocking the door. But then there's a lot of broadcast traffic I'm just not interested in. So I could say I want to see only frames from new IDs that popped up after a certain amount of time. So let's say after, I don't know, 3 packets or 4, it's going to be less when I increase it here. Yeah. You see? So 10C is like the 15th new ID. And you can also exchange data between the tabs here on the top. These are all the actions you can perform. So I can say I want to replay this packet, or I want to create a rule for this specific ID of this frame or for the payload of the frame. So right now, let's see how the man in the middle works. First, you want to, gotta resize it a little bit. Okay, let's add a rule. I want to swap the payload of any frame containing the ID 80. The condition value is used for the second kind of condition, which in this case is specific bytes match. So specific bytes of the payload have to match, and which bytes you will tell it by using the mask. I'm going to set it all 0 now because I want to have any frame from this specific ID to be changed. And I'm going to use like 1, 2, 3, 4, 5. Oh.
What?
Ah, that's the mask, yeah. Wrong field. 2, 3, 4, 5. Yeah, I'm going to show the actions first. Like you can do a lot of stuff here. But just for the sake of showing you, let's do this. Yeah, should be all set. Now we push the rules to the SD card. Successfully send rules. You see, like from the ID 80, the payload was actually something like this. So nothing remotely similar to the value I put. If we start the main in the middle, the LED will go orange, and I have attached a debugging tool on the second CAN port, which will contain the modified packets. Here we go. I better hide this one. And you can see
which one?
80 is 1, 2, 3, 4, 5, 6, 7, 8.
So it's actually modifying it in real time. I guess you can notice the latency is pretty much the same on those.
Yeah.
So. Okay, so should we keep on going? Are we? Yeah, we need to show the security access hijack and stuff.
All right.
Yeah, but afterwards, all the setup will be available in our booth. So if you guys want to see it again or want to play with it a little bit, just come to our booth.
Yeah, we will be happy to go into details of all the features with you at the booth.
So, yeah. Now, the next thing, security access hijack. Why? So, OEM tools and some third-party tools actually need to authenticate themselves to ECUs to gain access to restricted features, like, for example, updating the firmware or modifying some parameters, blah, blah. So these tools have fixed functions. It's just like a big button, like read, write, whatever, blah, but you don't get to change too much stuff. So, yeah. And why would you do it? Because you can. So, yeah. How does it work? So the thing is, you have a device, which in this case is the CanBadger, that is acting as a bridge, as a transfer bridge. So it's like forwarding all the traffic. But it is waiting for a security access request to happen. So it's actually inspecting all the traffic, but it is forwarding all the traffic. Then we have found ourselves within our pen testing vehicles that sometimes you get a security access hijack, but then you're not in the right diagnostics mode. So when you attempt to use the security hijack, for example, to run the memory, the ECU will reject because it will tell you like, no, I'm in the wrong diagnostics mode. So before keep on going with the security hijack, the CanBadger will actually switch to the diagnostic session type you have told it to, and then it will start forwarding the security access. And if the security access succeeds, then the CanBadger will cut out the external tool and will take control of the session, which leaves you in the desired diagnostics session mode with security access, without having to care about keys or algorithms or anything. So yeah, demo again. Let's see.
So now you will also get to see the CDC mode. The CDC mode starts automatically when a USB cable, actually when a computer is connected to the USB port. Yeah. So you don't need to set it up, it will automatically detect it.
I mean, we're actually using here Termite, which is just a terminal. Yeah. So that's a CanBadger interface for USB. Before we saw the Ethernet, which was the GUI. This is just like plug and play. It works on all OSs, obviously. So just for the sake of showing you like how it is normally. So you start a diagnostic session. Oh yeah, I removed the USB. Just a second. For the Ethernet. Where's the USB? Here. Plug it back. And reset. Yes, we got it. So let's go there. So let's start actually a diagnostic session. So yeah, your own ID would be 7E0 in this case for the test ECU. Did I type anything? Yeah. and 7E8 for the ECU, and let's say session type 01. So now we have a session actually, and we can, like, for the sake of testing, let's read data by ID, okay? So let's read the bin of the ECU. The ECU is the one we have here on the desk. So yeah, read the bin, but I get, oops, access to SID22 rejected because message length or format incorrect. Yeah, I'm not using the tester address. So yeah, let's change the mode while I'm still connected to using tester address. So let's enable it. Let's say the standard one, and let's add F1, which is the typical address. Okay, now we're using the tester address. Let's try again to read the bin from it. So yeah, this time we succeeded. We got the bin because we are using the tester address. So yeah, let's try, for example, I don't know. Let's remove the tester address quickly because you can also disable it in real time for your test. Let's try security access. So we'll use a known algorithm. We just implemented, like, for testing, like 1 or 2 security algorithms, we reverse it. So we're gonna use level 3 and the keys to FC9. So boop, access rejected because service not supported in active session. So that's what we were talking about earlier. Sometimes you need to be in the right diagnostics mode. So yeah, what should we do? So let's go to diagnostic session control and let's scan for available session types.
Yeah, so the authentication is not like binary. You have different levels of privilege.
Yeah. So yeah, so we scan, those are the available modes. So let's then switch. I like 4F. 4F looks like fun. So let's switch to a custom session and let's make it 4F. And okay, so now we have that. Let's try security access again. So the same thing again, and to FC9. So yeah, now security access granted. So now we're in the ECU. So now if we want to read memory, for example, let's read memory by address. Let's start from TH0000. Let's read 10 bytes. And there you go. There's a dump from the memory from the ECU. So that's like the normal way. I mean, you know the algorithm, you know all the stuff, right? So let's terminate the session. Let's suppose I actually do not know the key, I do not know the security access. So obviously, if I try again, I'll just tell you, let's not make this too long. If I try to read the memory without security access, the ECU will tell me, yeah, just go away. Like, you're not reading my memory. So what are we gonna do? We're gonna hijack a security session. So let's go into protocol menu, let's go into security access, let's say hijack UDS, let's say 7E0, let's say 7E8, let's say any security access level, which is 00. You can also set a specific level if you want. And yeah, I want to be in diagnostics mode 4F because remember it didn't work on mode 01, so I want to be in 4F. So let's say, yeah, switch to 4F. So now it's waiting for any traffic to happen to map where on which connector is each ID. So let's give it some traffic. We happen to have a tool which I like a lot. It's called MPPS. It's a Chinese clone. The original one is really awesome, but for testing we just needed like a cheap one, so we got the clone. Bad for us. So yeah, let's see, read ECU ID. So you see, I read the ECU ID, so I get data. But yeah, what did the CanBadger do? The CanBadger already mapped the IDs, and now it's waiting for security access. Okay, so yeah, let's give it some security access. Let's read the flash. But an error has occurred. And we got the security access. So just to show that it is really a security access, let's try reading the memory. And yeah. What did I present to us? Oh, so again, and let's say 10 bytes. So you see, we're able to read the memory. So we actually hijacked a session on the diagnostics mode we wanted to, and now we're able to read the memory without knowing. And again, just to show that it is not possible without the security access, let's go in there really quick. 078 and 0, 1. Actually, let's go for 4F. If I try to read memory, it's just gonna say no because security access required. So yeah, we previously hijacked the session. So that's how it works. And let's get...
So remember, any device that can solve, any tester that can solve the challenge for you is going to be the door opener if you hijack the session, and you can do anything you want there.
Yeah, and then you have full control to scan memory ranges, to try some other stuff, even to write, I mean, to change some parameters. You can do anything without caring about the security itself. So yeah,
I sort of mentioned that already. Because UDS and TP are so handy, right? They split up your packets and you just need to care about the payload. Some manufacturers like to distribute firmware updates over the CAN bus, so to different modules. You know, it will get like an initial one either from the factory, I don't know, HTTPS or whatever, and then it will distribute each firmware update to the modules. The CanBadger can grab these ones on the fly and lock them to the SD. It will automatically look for those transfers, and you can tell it to dump the binary outs on the SD card. And this is very interesting because on the way to the car, it might actually be decrypted. So if you're looking into that, you will just see some ciphertext. But on the CAN bus itself, mostly it's not encrypted.
So yeah, we survived sort of the demos. So yeah, what else can the CanBadger do? So like he was just mentioning, it can dump TP and UDS transfers, which are used for firmware updates. It can spoof OBD data through man in the middle and emulator. We just saw it. We didn't talk that much about emulator though. We will do it now. Yeah, the GPIOs can also be used for bootloading, like in tri-core microcontrollers. And you can manipulate other signals via UART pins.
So we wanted to make it very easy to take the CanBadger, not only to build it like with cheap components, it's also very easy to solder. But on the software part, we also wanted to make it easy to add like your own stuff, for example, SIDs for parsing or other functions for automatic testing, whatever. So just some instructions if you want to get your hands on it. You will have to get the LPC Espresso IDE if you really want to work with it, but you can also use the Embed online IDE, which comes with a nice compiler which actually optimizes a lot. The CanBadger server is written in Python and Qt. You just need 2 or 3 dependencies, mainly Python 2.7 and 2 packets from pip. It's all GPL, we already published it. You can look it up on GitHub. Yeah, that's pretty much it.
And yeah, just to get back to the emulator, we didn't talk that much about it. Actually, we missed some slides. So what the emulator does, that's another function that we recently implemented in it. You connect the CanBadger to your vehicle. Okay, so we talked about standalone mode, which doesn't need anything. To use the standalone mode, the CanBadger has a small push button on the bottom. So depending on how many times you press it, it will go into one mode or another. It can go into login CAN traffic, login it in transport bridge. It can go into emulator. It can run man in the middle. So you just preload the rules, press the button, and then it will act as man in the middle independently. No laptops required. And so the emulator function will just look up on a configuration file in the SD. It will send the frames that you specify there, like raw, and grab the replies. So with that, what can you do? You can, for example, like he was mentioning earlier, go like for a walk, I don't know. Let's say that my company is monitoring how I drive, like because I'm a delivery guy, whatever. And yeah, I really want to go, I don't know, man. I want to go somewhere, but I don't want my company to know. So what do? I will use the UART to inject GPS data, because most of the USB OBD2 dongles use UART for a GPS interface. Then with the emulator, I will record me doing what I'm supposed to do. And afterwards, when I start it, it will play back time-wise all the data. So actually, it will not just like vomit the data it captured, it will keep timestamps, and then within the timeline, it will provide the data that was recorded. So it's a real, true emulation. So with those two, you can completely fool both insurances, companies, all the dongles. So pretty much all the data that comes over OBD2. And yeah, but we did that because we're too lazy and stuff. So
yeah, don't want to be tracked.
Yeah. No. And yeah, that's pretty much everything about emulators. So yeah, we still have some time. So we already talked about this. So what we're gonna do is, yeah, let's talk about where everything is.
Here you will have the link to our GitHub repository. That's like a small page covering an introduction to the CanBadger and some links. The CanBadger server has its own repository, but all the rest, the slides from DEFCON, Black Hat, and everything like documentation-wise will be in the CanBadger repository as well. We encourage you to have a look at it. Maybe you have some nice idea which you can have. You can write us privately, but on GitHub you can like make issues for all sorts of stuff. So that would be very cool.
Yeah, because we all know you're hungry, and we are too. So yeah, as we said, thank to you all for being here today, not just with us, but at hardwear.io. Thanks to CodeWhite for their support and their trust in the project, and to our family and friends that support us even when we run out of coffee.
Yeah.
So,
thank you very much.
Yeah, so we are going to go for questions. So does anyone have any question? Okay, wow, we did so good, man. So yeah, anyway, feel free to come anytime to the booth. We'll be around, and we can do the demo all over again. You can play a little bit with it. So yeah, enjoy lunch and enjoy hardwear.io.
Thanks for having us, guys.